So as we continue for our problem, a horizontal curve on a 4-lane highway has a super elevation of 6% and a central angle of 40 degrees. The PT of the curve is station 322 plus 50 and the PI is at 320 plus 08. The road has 10 feet lane and 8 feet shoulders on both sides with high retaining wall going up immediately next to the shoulders. What is the highest safe speed of this curve? And what is the station of PC? So for this one, of course, if we're going to draw our curve, so this will be our curve. So basically, this is our PC. This will be our approximately our PT. So if we try to draw a tangent line, so the intersection is our PI. And from PC towards PI, that is our tangent line. And of course, this is our L. So that is our L, which runs from PC towards PT. So therefore, we are going to identify the value for our PC. So that we can solve for the station at PC, we make use of the given station. So we have to make use of the equation for solving for the radius. So using the variable tangent length and the length of the curve. So we have to take note that our tangent tangent length T is equal actually to the station of PI minus station of PC. So since PI station is given, which is equivalent to 320 plus 08, then minus our PC. Then the length here of the curve will be equivalent to the station of PT minus station of PC. So station of PT is 322 plus 50, then minus PC. Now from our equation, R is equal to T all over tangent delta all over 2. Then our R is equal in terms of the length over pi times delta all over 180. So equating this one, we can have the equation T all over tangent delta all over 2 equal to L all over pi delta all over 180. So therefore, if we're going to substitute the values now, if we're going to substitute the value, so if we're going to substitute the value for our T, which is 32,008, this is actually now minus PC, and our L is equal to 32,250 minus PC. You just have to take note that we just converted our station into feet. Actually, this is 320 plus 08 station, or that is 32,008 feet. This is actually 322 plus 50 station, or this is equal to 32,200 feet. If we're going to substitute that one to our equation, T all over tangent delta all over 2, we have derived a while ago, which is equal to L all over pi delta all over 180. So this is 32008 minus PC all over tangent. This is 40 all over 2 equal to 32250 minus PC all over pi times delta all over 180. So therefore, our PC now will be equivalent to this is 317 plus 44.25. This is the station of PC. So you have now the station of PC, and we have to compute now for our R. So our R, using our T value, our T here is equal to using this equation, so 320 32,008 minus our PC, which is actually equivalent to 31,744.25. So we can have the value for our T, which is 263.75 feet. Now, using our equation R is equal to T all over tangent tangent delta all over 2. So we simply have to substitute 263.75 all over tangent 40 all over 2. So this will give us a value of 724.59 feet. So we have now our value for our R. So we have to take note that the curve radius is usually taken to the center line of the roadway. So on the center line of the roadway, there are two lanes before the center line. So meaning to say you have the center line, then there is two lanes before the center line. So before the center line, there will be two lanes. So which means that if this will be our center line, this is our center line. So which means that if this is our center line, so we have here before the center line, so we have this lane which is 10, and this is also 10. So actually this is actually the center line. Wait lang. So therefore, if we're going to have this one, this will be the position for our R sub V. This is our R. So therefore, our R sub V is equivalent actually to R minus 10. We have here 10. Then minus, you have 10 all over 2. And basically, this will give us here the value for our value will be equivalent to 724.59 minus 10 minus 5. So it will give us 709.59 feet. So we have to take note that from table 3.5, so our super elevation, which is 6%, if we're going to have the design speed of 45 miles per hour based on the table, it needs a radius of 643 feet. If we have 50 miles at 6% super elevation, 50 miles per hour, the radius is equivalent to 833 feet. So therefore, if we're going to have here if we're going to compare the values here, we're going to the highest design speed for a centripetal force, which is 45 miles per hour. So we're going to adopt 45 miles per hour since the value for R in our computation, the value for R sub V, which is 700.59, is greater than the design's speed. Is greater than the radius as illustrated on the table 3.5. So this is greater than 643. However, if we're going to choose 50 miles per hour, this is 709.59 is smaller than 833. So it will not be sufficient. So this 50 miles per hour is not acceptable since it has an insufficient radius. So we're going to have the value for our design speed will be 45 miles per hour. So this will be our equivalent value since it provides a sufficient radius, since our computed is greater than the allowable radius, which is 643. Then we're going now to check for adequate sight distance for M sub S, which is going to be the shoulder width plus half of the inside lane width, or that will be equivalent to, so which means that for our M sub S, if we're going to check our M sub S, this will be the shoulder width plus our half of the inside lane, half of the inside lane. So therefore, this will be equivalent to 8 plus 10 all over 2. So you give, because the shoulder width is 8 and our half of the inside lane, inside lane is 10. So we're going to have half of that. So this gives us 13 feet. So if we're going to consider the stopping sight distance required at 40 miles per hour, at 40 miles per hour, the required stopping sight distance is 305 based on table 3.1. So from table 3.1, you have to take note that you're going to have table 3.1 for a 40 miles. We consider now the design speed of 40 miles per hour. So the SSD, the stopping sight distance for 40 miles per hour based on table 3.1 is 305. So we're going to check now our M sub S. So we're going to check this, which means that the formula is R sub V, 1 minus cosine 90 SSD all over pi times R sub V. So we simply have to substitute 709.59 times 1 minus cosine of 90 times 305 all over pi times 709.59. So this will give us 16.34 feet, which is greater. This one is greater than our 13 feet of available for the available MS. So the 40 miles per hour is too fast since the value for this is greater than 13. So we're going to consider a 35 miles per hour. So if we're going to consider 35 miles per hour design speed, our SSD from table 3.1 again is 250 feet. So if we're going to substitute that to this equation, so substitute the values for that equation. So we have here 709.59 minus times 1 minus cosine of 90 times 250 all over pi times 709.59, and the result here is equivalent to 10.99 feet. So therefore, since 10.99 is less than our 13 feet, so the highway is safe at 35 miles per hour. So we're going to have the design speed of 35 miles per hour, considering both the maximum safe speed for centripetal force and sight distance. So the lower two speed will govern. So which means since at 35 miles per hour, our MS is the computed MS, which is less than 2 the design MS. So we're going to consider the lowest in value for the design speed. We will not consider the 40 miles per hour. We're going to consider the 35 miles per hour, which is the highest safe speed for sight distance. So the lower the speed and is the highest safe speed for this curve.